We're talking a little bit about assembly language right now. We've been looking at machine code so far. Machine code is difficult to write programs in because you have to remember things like, hexadecimal 49 means read in a character, or hexadecimal digit 51 means maybe print a character. It becomes really difficult if every time you want to do something you have to think of a number to go with it. As human beings, we have a vocabulary, a set of words that make sense to us. We call these things mnemonics, and assembly languages translate between the mnemonics that make sense to us as human beings and the numbers, the patterns of bits that make sense to the CPU. Assembler is a program whose job is to do that translation. In PEP 8, there is an assembly language, a set of mnemonics that very, very closely correlates with the patterns of bits in the opcodes of your machine language instruction. For instance, stop would be 0, 0, and char I and char O, I believe, are hex 49 and 51. But it's much easier to think of them as read a character in or write a character out. These short names provide us with a concise but also human understandable way to talk about our programs. Also, when we're passing data into these instructions as direct or immediate mode access, instead of using the last 3 bits 001 or 000, we can just write an I or a D in the assembly program, and it will generate the machine language instruction with those bits set properly. So this is just a more human readable way to specify a process to the computer. It requires an extra program to do the translation. This other program is called an assembler. It reads in a text file and it produces out machine code. When we're writing text to that file, some of the text that we write will be those mnemonics, and other text will actually be used to configure the translating program itself. So for instance, these pseudo instructions that begin with a dot will be used to tell the translator, hey, stop translating. Literally just copy these ASCII character codes to the new outputted program as bytes of data. Or it'll tell it, take this, have uninitialized random block of 2 bytes there. Or here, I'm going to give you some hexadecimal, and I want you to take that hexadecimal and write it out as patterns of bits in the machine code. So, you've got those things in addition to regular old translation. Here we can see a program in another video. I'm going to pull this up in PEP 8, and I'm going to demonstrate this running. It prints hello world using assembly, and if you'll notice, it's probably much more readable. The one thing about this program that makes it the most readable is that it's using comments at the end. So each line of this file would generate a different machine language instruction. The line starts with the machine code mnemonic, that's like the first 4 or 5 bits, the operand, and the addressing mode immediate or direct. A semicolon ends the line, and everything after that is completely ignored by the translator. It's there for human beings like you and me to tell each other what we actually mean by this slightly incomprehensible but better than machine code explanation of a process. In PEP 8, it looks a little bit like this. I'll actually demo that live. And I'm going to end with this figure, which is the thing to keep in mind when you're imagining the process of an assembler. It starts with a program in assembly language, and by a program we just mean a text file. And it takes that as input to a piece of software called an assembler. Assembler is just another program that is written in machine code. It was probably originally written in something else, and an older version of an assembler made the machine code. You have machines making machines, right? So you have an assembler that produces output from the text that is a program in machine code. If you were to open it up and look at it, you'd see a whole bunch of gibberish ASCII characters. It's just bit patterns. This is ready to go right to your CPU's memory and be executed. I'm going to now go to PEP 8 in the next video, and I'm going to do some demo programs.